Welcome to classes on organic chemistry. Today's class is class number 9. It is the continuation of class number 8 and it is general organic chemistry, higher secondary first year. In my last class, I taught about polarization and polarizability. And polarization was a permanent effect and polarizability was a temporary effect. Now, polarization effect are of three types. One is inductive effect, other is mesomeric effect, and other is hyperconjugation. Now, what is inductive effect? In a very short way, if I tell you, this is simple carbon chain where there is no polarization, and in the second carbon chain we have added X, and in third one we have added Y. So if X is electronegative, more electronegative than carbon, then the bond pair will be attracted towards itself. So it will be partially negative and it will be partially positive, and the positivity will extend with lesser extent towards the left carbon. And it is actually found that up to 4 carbon or 3 carbon the effect is seen, and beyond that carbon the effect is not seen, not observable. Now if this Y has, if the Y is electron releasing group and it releases electron towards carbon, then this will be become del positive and this will be become del negative, and del negative will be like this. So as you move towards this way, the negativity will decrease, gone. So in a nutshell, what we say, that when in a nonpolar carbon chain a group is attached, if that group X draws electron towards itself, one effect appears like this, and if Y pumps electron, release electron towards carbon, then another action occurs, electron pumping occurs. In both the cases there is polarizability, there is charge separation, and that effect is called inductive effect. Now inductive effect is actually permanent effect, and which is not absolute, it is relative, and this relative effect is always compared with the standard CH bond, and whose inductive effect is termed as 0. If that hydrogen carbon has more electron withdrawing capacity of than hydrogen, then that effect is called minus I effect. And if Y has electron pumping ability more than hydrogen of CH bond, then it is called plus I effect. So out of plus I and minus I effect, there are some groups of minus I group. That groups are very important, you should know, otherwise you will be very weak in chemistry. It is very important, and there is nothing to learn by heart. You just listen my lecture and you go on, your concept will be built as usual. So minus, I have maximum of the Manasa effect of the groups or atoms or groups of atoms. I have arranged in increasing order of the electron withdrawing capacity: NH3, NO2, CN, SO3H, CHO, CO, COOH, COO, R, COCl, CONH2, fluorine, chlorine, bromine, iodine, and phenyl, and hydrogen. Each and every has the ability to attract electron towards themselves. They have got electronegativity, they withdraws electron, then these are called Manasai group. The increasing Manasai group, they are with respect to hydrogen, their ability is more. All these groups are called Manasai group. Now what are plus I group? Those which pumps electron in the carbon chain, like Y, it is plus I inductive effect. These are Again, the plus I effect is plus I effect can be arranged in increasing order, in decreasing order, like this: tertiary alkyl group CCH3 CH3 3CH3 group, secondary alkyl group, and primary alkyl group, then methyl group, then hydrogen. That is, in comparison to hydrogen, these groups have the more plus I pumping effect or more electron releasing capacity. Now, if I ask you to arrange in increasing order of acidity of these acids, now you should compare this. You should apply the concept of plus I effect, because there is plus I group attached to this. Now, what's happened? Just I am telling. Say the COOH group may be written as this. If this is acid, it should have the ability or desire or tendency to remove hydrogen as proton, then it is acidic. A species is acidic in protonic concept if it has the ability or if a tendency to lose hydrogen as proton is called acidic. So if there are some effect attached with this, and this effect facilitate the release of proton with a greater ease, then that will be more acidic. So now let us see, it is acidic because of the fact CO group is electronegative group. That's why oxygen is removed as O positive. Therefore, formic acid is acidic. Now both are acidic, no harm, no matter. But now here in this group, CH3 group is there. Here it is CH3 group. So CH3 group means electron pumping group. This is plus I effect. There is one plus I effect here, and then due to this effect, the electron will pass throughout the chain and the density of electron will increase. It will not release as proton as this, where there is no CH3 group, no pumping groups are there. That's why it is less acidic than this one. Now if you come to this one, there is CH3 CH2 means ethyl group. More is the chain of the group, more is the plus I effect. So from CH3 group, the CH3 CH2 group has more plus I effect. So here the density of electron will increase furthermore, then release of hydrogen as proton will be difficult. So it is further less acidic. Now another one, we can now you see in carbon we have 3 chlorine, and you just take one example, you can understand. Here iodine chlorine is electron withdrawing group. I have shown in the list. It is electron withdrawing group, so it withdraws electron. So when it withdraws electron, the low electron density or the electron flow will be like this. So this bond will become weaker. So this will facilitate the removal of hydrogen as proton very easily. So here 3 minus I groups atom element chlorine is there, minus I species chlorine is there, here 2. So out of effect, this effect is weaker. Now if you make it CH2Cl COOH, if you remove one chlorine, then again you are reducing minus I effect. So more the minus I effect, more is the acidity. Acid, you can explain the strength of acidic nature of different compound. Now we can explain the basicity with the help of both the species are base. Base In terms of protonic concept, the species which has lone pair of electrons are called base. This ammonia has lone pair of electrons, CH3 methylamine has lone pair of electrons. Both the species are base. Now, if I ask you which one is more basic, then which one is more basic and which one is less basic, means which of the compound will very easily donate or uses this lone pair of electron to other bonding. Am I right? The species which can very easily donate this lone pair or uses or utilize this lone pair of electron to make a bond with other is called more basic. So basicity depends upon the ability of this one, and if there is any effect acting upon these two species which makes the availability of this lone pair of electron easy, then that one will be more basic. So here NH3, there is no CH3 group is attached to it, but there is amine, there is CH3 group, so it pumps electron. So whenever it pumps electron, that one easily will be available for bonding. So due to plus I effect, this is more basic than ammonia. So these are the some application of acidity and basicity in terms of plus I and minus I group. Second permanent effect was mesomeric effect. It is very important. Mesomeric effect or resonance effect. Mesomeric effect, resonance effect. What is mesomeric effect, resonance effect? I am not giving definitions. When I will give you a practical example, you can understand it very easily. So, butyrate diene. When pi electron is withdrawn from multiple bond, you listen minutely, multiple bond to the atom or from multiple bond to single covalent bond, or one withdraws multiple bond to atom or multiple bond to single covalent bond, or say this is another compound. Here there are lone pair. So here lone pair from atom to bond. So the condition is that when pi electron is withdrawn from multiple to atom or from multiple bond to single covalent bond or lone pair from atom to bond, that phenomenon is called mesomeric effect or resonance effect. Both the effects are same in this concept, but there is a difference. I will tell. So here you see that pi electrons is withdrawn in this way. So it is giving when it is withdrawn here, it will give a lone pair. So that withdrawn electron is here, it is negative, and bond is oriented in this way from this place to double bond, from multiple position to single covalent bond. Am I right? So it is deficient. So this is plus and this is minus. Again this will come to its position, again this will come to this position. This is balanced, it will go to its original part. Again if it come to in this position, it will go to this position, this will go to original position. That phenomenon is called resonance or mesomeric effect. Now you see here also a lone pair from atom to the bond goes in this way. There is problems in the 4 valency of carbon, that bond is withdrawn towards more electronegative oxygen. So what's happened, that double bond becomes here single bond, lone pair of electron in terms of negative sign appears here, and that lone pair come over to this place is double bond. Oxygen had got 3 valency, it is positive, unstable, this is negative. In other places it is other time it comes its original position and it goes to its that position. Am I right? It go to its original position. Both the phenomenon is called a resonance. But the condition is that where is the difference between resonance and mesomeric effect? In resonance and mesomeric effect, both the places, both the system there is withdrawal of electron, withdrawal of electrons, or displacement of electron from multiple to a single covalent bond, from multiple to single covalent bond, multiple bond to atom, or for lone pair of electron from atom to bond. Both are the same phenomenon. But in case of mesomeric effect, the condition of alternate single and double bond is essential, is a must. Mesomeric effect, it is a must. In mesomeric effect, the condition of single double or double single alternate double bond system must exist, otherwise mesomeric effect will not affect. But in resonance, uh, uh, either there is alternate single or double bond is there, it will okay. But if there is no single bond double bond, there is no such system is there, again it will apply. But there is no condition restriction of alternate single and double bond in resonance effect. Without that system also resonance effect appears, but in mesomeric effect this condition must be fulfilled, otherwise mesomeric effect will not occur. This is the basic difference. Or other thing you can write in this way: it is more electronegative, bond is withdrawn in this way, am I right? So when bond is withdrawn, it is positive, am I right? And this is negative, it is negative. That condition is resonance. But here there is no mesomeric effect, only resonance is there. It is exclusively resonant. Next one, third one is hyperconjugation. Hyperconjugation is also. So before explaining what is hyperconjugation, no bond resonance, I am to first tell you that system must be sp2 hybridized, or system may be alkene, or system may be alkyl free radical. If the systems are like this, then hyperconjugation is possible. Now what is hyperconjugation? Let me explain with a very important thing you can very easily understand, because maximum of you know that methyl is methyl CH, means in toluene CH3 group is ortho n paradirecting. There is minus and there is minus, but maximum of you do not know how minus appears. You can't explain it how minus appears here, ortho meta, not meta, in para position. So if CH3 group in toluene CH3 group is there, so incoming electrophile either will enter in ortho position or in meta position, because ortho and meta positions are comparatively electron rich than other position, than meta position. Electron rich center, so electrophile electron deficient center, we are coming later on. Electron deficient center will come here and replace one hydrogen only in ortho and para position. Why this so happen? Why there is negative sign and why there is negative sign? This can be explained with the help of hyperconjugation. Now you see, no bond resonance means that bond will be vanished and this will be plus. When that bond is vanished, and that bond will just come over this, and I will show only one. So you see, the fact is, you see, without any bond, it is side by side existence of H proton, H positive is side by side, bond is not there. Bond is not there. Bond is not there, but bond has inclined here. As soon as bond is inclined here, there is problems in the double bond. That double bond will withdrawn here. So what you get here is we get minus sign here, and other two bonds are in the same position. Instantly what's happen? Again, this will exactly delocalize in this way, and that bond will withdraw. That is in ortho and para you are getting two negative. But that mechanism, that phenomenon occurs three times. Once this is H positive with no bond, other time it will again come to its original position. And that hydrogen will be like this, and there will be double bond like this phenomenon. And instantly this will again come to its original position, that hydrogen will be plus and this will be double bond like this. So it will give a mechanism phenomenon like this. So that is called hyperconjugation or no bond resonance. So hyperconjugation is also possible in case of or no-bond resonance is possible in case of sp2 hybridized systems. Now what is sp2 hybridized system? Say it is ch3, it is c, it is ch3, it is ch3, and if you calculate, this is 1 bond, 2 bond, 3 bond, that 3 bond is sp, it is 1, it is 2, it is sp2 system. It is carbocation. Am I right? 3-degree carbocation. We are coming on this one, 3-degree carbon later on. So what's happened? It is possible. We can explain the hyperconjugation here. We can explain the stability of this one. So later on, if carbon has no hydrogen, then it is carbocation. If carbon has one hydrogen, it is 2 degree. Carbon has two hydrogen, it is 1 degree, or CH3 positive is also 1 degree carbocation. So now you are very often asked to tell the stability of this one. We know the stability of this one in your book. It is very easily explained. The more the plus I effect, it is plus I effect. Am I right? It is plus I effect. More the plus I effect, more the electron releasing tendency towards this positive carbon in p orbital, more is the stability. So here it is more CH3, here only 2 I group, here only 1 I group. So less the number of I group, less is the stability. More is the number of I group in the carbocation, more is the stability. Now in terms of hyperconjugation, you can also explain it. You see, if this hydrogen, if you draw this hydrogen like this, if you write this hydrogen like this, again by no bond resonance, what you can do, you just banish this one and incline the bond in this way. You make it no bond resonance. Am I right? So that plus will be banished. Am I right? No bond resonance will occur. For that carbon, again this thing will happen. For that carbon, this thing will happen. From 3 carbon 3, and from there will be 9 resonating structure in which no bond resonance will occur. So 9 resonance structure, the plus will be scattered around the whole area. When the plus charge of the carbon is scattered or diffused in the big and the high area, then this get lesser amount of energy, and that will get more stability. Here the possibility of scattering of this positive carbon towards the larger area is restricted by one CH3 group. Here 3 CH3 group, that CH3 group will do so, that one will do so, that one, but here the 2 CH3 is doing the same mechanism. So the diffusion of this plus charge with a lesser area, here diffusion of plus charge is lesser area. So in terms of inductive effect also, more the CH3 group, more this plus will be diffused in bigger area. That charge through hyperconjugation will be diffused in lesser bigger area and still lesser. So if it is diffused in more area, the stability energy is less. It is the least energy, it is a bit more, it is than more. So more least the energy, more is the stability. That's why with the help of hyperconjugation, you can polarizability effect. These are temporary effect. So this is inductomeric effect. Now what is inductomeric effect? Just with an example I will explain. The chlorine has some electronegativity, more electronegativity than carbon. It want to go out from this one, but it will not detach, because 1 degree carbocation is not easily formed. It gives generally transition state in the reaction mechanism we will find. So how that happens, how this chlorine goes out? So inductomeric effect, this is inducted, this minus will try to attach with the reaction center carbon, and that will try to go out, otherwise it cannot go away. So we are inducing some reagent to take chlorine out, that is called inductomeric effect. Now what's happened here, it is transition state. Later on we will get that O is bonded in a very temporary manner, and this is called transition state. That happens, and in the final stage, it is transition state. In the final stage, OH will attach and inversion occurs. You will get later on this. That is, in presence of OH, the chlorine is going out. In absence of this will not happen. So it is inducted. That's why it is called inductomeric effect. Now second effect is electromeric effect. Very important, and very often you will come across this effect. So very simple, I am showing you a reagent. Say this reagent is Cn, HCN or Cn. Am I right? This is negative. So what's happened? In presence of this reagent, in presence of this reagent, in presence of this reagent is negative, this bond is withdrawn in this way. Oxygen is more negative, but it has a tendency to withdraw the lone pair of bond pair of electron towards itself. So it has withdrawn electron, and it will become plus, and in this plus it will enter. So this effect, withdrawal or displacement of electron, occurs in presence of Cn. Now when that Cn is withdrawn, then this will come to its original position. When Cn is given, that appears. When Cn is withdrawn, again it comes back to its original position. That will come its original position. So in presence of some reagent, if displacement of electron occurs, and in absence of this reagent, if it takes its original position, original compound, go back to its restore its original structure, then that phenomenon is called electromeric effect. Very important phase of the organic chemistry has now come. Now you minutely follow this thing, mechanism of organic chemistry. So if you explain the mechanism, means how the reaction takes place, the step by step information or the showing of process is called mechanism, stepwise mechanism. So first of all, in short, let me explain what is substrate. What is substrate? Say HCN. So this species reacts this. So the species which is attached attract the species which is attracted by the other is called. So it is the species which is attracted by the other reagent. That species is called substrate. Now what is attacking reagent? Attacking reagent, earlier I have told, here this is attacked, this is attacking this one, it is substrate, and this is attacking reagent. Now third one, intermediate. Very important thing, intermediate product. Now what is intermediate? It is substrate and attacking reagent combinedly gives highly activated, highly energy giving species, having a species with high energy, highly activated species before giving product, and this species before giving the product, another species is called intermediate product. Species is called intermediate. Say A plus B gives something in the middle before giving the product, that species is called intermediate. So substrate plus attacking reagent gives activated species, highly activated species before giving product is called intermediate. Intermediate are how many types? I am telling, I am not writing: carbocation, carbanion, free radical, carbene, and benzene. Intermediate, let us tell something. If the reaction involves breaking and forming of bonds simultaneously, the mechanism is called concerted mechanism. Now, if the reaction involves breaking and breaking and forming of bonds simultaneously, the mechanism is called concerted mechanism. And if the mechanism of reaction involves the formation of intermediates before giving the product, the mechanism is called non-concerted mechanism. So we are coming intermediates, carbocation. So you know the carbocation which has 3 bond or 6 electron, 3 pair of electron, or 1 2 3 4 5 6 electron and 1 positive charge is called carbocation. And hybridization is sp2, 1 2 3 bond sp2, 1 2 3 bond, 1 2 3 bond sp2, it is sp2 hybridization. And its geometry is trigonal planar and bond angle is equal to 120. And what is carbanion? Carbanion is equal to 3 bond pair, another bond electron pair. So 1 pair, 2 pair, 3 pair, 4 pair of electrons or 8 electrons, it is called carbanion. And that carbanion is having sp3 hybridization, because here 1 bond, 2 bond, 3 bond and lone pair or 1 bond, that is also counted as 1, there is 4. If it is total bond pair 4, so 4 is sp3s 4, am I right? It is tetrahedral and bond angle is, and what is free radical? Free radical odd electron species, there are 3 pair of electrons, 6 electron and 1 dot, that is called free radical. And its hybridization, free radical is not counted, this odd electron species is not counted in finding out the hybridization. So 1 bond, 2 bond, 3 bond, 3 bond, it is sp2 hybridized. So it is like this, angles are like this. So I have got carbocation, carbanion, free radicals, and other is carbene, and other is benzene and argonitride, another is, these things are not included in your chapter. If you ask the stability, I have already explained, more the plus I effect, more is the stability. Here 3 plus I effects are 3 CH3 groups are plus I effect, and these are pumping or releasing electron to plus. That's why it has got less energy and it's got highest stability. And there is 2 pumping group, there is 1 pumping group. So in this way we can explain the stability of this one in terms of plus I effect. Also in terms of hyperconjugation you can explain if there is no bond resonance. I have shown earlier, I have shown it earlier. So now for carbocation, this is 1 degree, this is 2 degree, and this is 3 degree. The matter is reverse of this one, because there is negative charge is centralized on carbon p, dumbbell shape p. There is localized negative charge, and more the localized charge is, more is the instability. Hence, due to localization of plus charge on p orbital, vacant p orbital, so what's happened? These 3 groups are pumping. These are also releasing electron. So more and more electron density is now accommodated on the p of carbon. So more is the concentration of the negative charge, more is the energy, low is the stability. So here pumping is 2, here pumping is 3, here pumping group is 2, less accumulation negative charge, less accumulation of negative charge, less accumulation of negative charge, less is the energy, more is the stability. The stability order is the same. And for free radical you just give here dot 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 dot, and it is the same as the 3 degree is greater than 2 degree, that is greater than 1 degree. That can also be utilized in that can also be explained in terms of next reaction mechanism is fission of bonding. These are very simple, nothing to learn, just you listen. Bond fission. How does bond breaks? If between A and B the bond breaks exactly in the middle, then what we get is called free radical. That is called a homolytic bond fission. And if the A is more electronegative than B, like this, the bond is attracted in this way. So this bond is inclined toward this. If A is more electronegative than B, so A is negative and B is plus. That is called heterolytic bond fission. So bond fission is of two types. One is homolytic, other is heterolytic. Nothing to explain more. Now, attacking reagent. What are the different type of attacking reagent? Electrophiles, those who loves electron. All carbocation species. Fluoride, bromide, plus part species. Electrophile. Because these are deficient in electron, then they will love electron to have. That's why they are electron loving species. So all the cation species are electrophiles. And another species you see AlCl3, BF3, etc. are also electrophiles. There is no plus or minus charge is there, no plus charge is there till they are electrophiles, because they are deficient of electron. You see, they need 8 electron, or aluminum need 8 electron around it, so we are getting 6 electron. They are deficient species. All deficient species are called electrophiles. Also they are called Lewis acid. All Lewis acids are electrophiles. So electrophiles may be cationic species, and here you see SnCl4, PCl5 expanded sextet, expanded form. So PCl5 10 electrons, SF6 12 electrons. If they are expanded sextet, then these are also electrophiles. So electrophiles generally you get three types. One is plus charge, other is deficient species, other is extended, expanded species. Now nucleophiles. Nucleo means nucleus. Nucleus means proton. In nucleus there is proton. Proton loving. Proton loving means loves proton, means loves positive charge. Those species which are negative in nature will love proton. Say Cn, say OH, etc. These are negative species. Say chloride, bromide, iodide, negative species. They loves electron. They are nucleophile. They are species with negative charge on it. Also, say ROH, there is lone pair of electron. Say RNH2, lone pair of electron. Say OH, lone pair of electron. If there are lone pair of electron, they are also electrophiles. So they are also nucleophiles. And emidented nucleophile, say this is also nucleophile, but this is a special type of nucleophile which are embedent nucleophiles, because they can attract the attacking reagent substrate through carbon or through nitrogen depending upon the nature of the solvent or nature of the substance, substrate, and lots of things are there. So they have the possibility of attacking the substrate either through C, either through N, or through O, or through N. So this type of the species are ambidentant nucleophiles. So these are in preparation. I have prepared you to go through the mechanism of the reaction. I have explained the system at a substrate, attacking reagent, intermediate, also bond fission type, also attacking reagent, electrophile, nucleophile. If you know all these things, nothing to learn by heart. If you know these things, now I will, in my next class, I will come with the mechanism, how it appears, what is SN1, what is SN2, what is E1, what is E2, what is U1CB. I will explain so that you can very easily understand if you have the knowledge on this. Thanks a lot for watching the class. Hope for the best for the next class.